Syzygy, Season 2, Episode 5, Exotelescope Expeditions. And welcome back to another edition of the Syzygy podcast. My name is Chris Stewart and I am sitting, as ever, around the round table in the office of one Dr. Emily Brunsden. Emily, how are you doing today?
Hello. I'm a little tired.
A little bit tired. Emily is going to get on a plane in a couple of days and go to almost literally the other side of the earth, down to the Antipodes, by definition, New Zealand, going down there for Christmas. Bit of work as well while you're there,
Yes.
or is that just incidental?
Yep, some project work, yep.
Yeah, but a very long flight with a very small child. Godspeed. Good luck. And in the preparations for that, you're a little bit weary.
Yes.
A little bit weary.
Yeah.
Well, look, we'll take it easy on you today. We'll go
that's all
gently. We'll go gently into this episode, which is episode 5 in the series of Exo Things. And today, when we were sort of going through the list of like what are all the different exo things we did, exoplanets, obviously, we got there. We did two, basically. We did sort of coming up to date and then looking into the future. We did Exo-moons, which was entertaining. We did Exo-comets, which was a new one to me. But today, for this one, Emily said, why don't we do exotelescopes? And I thought, I don't understand. Because the whole point of exo is like not in our solar system.
Correct.
And I think telescopes are in our solar system. So,
most of them
the
are.
whole point of exotelescopes, I just had this brain freeze of, I've got nothing. I've no idea. So, Emily, can we just start with what? Exotelescopes. What are we talking about today?
Well, yes, we are talking about telescopes that have left the solar system.
Ah, right. So it's not, right. So exo-moons, exo-comets going around other stars. We're sort of backing up. We don't have any telescopes around other stars.
No,
not yet. But in the sense of beyond our solar system, do we have any telescopes beyond our solar system?
We've got two.
And they would be?
Well, our very favourite friends, Voyager 1 and Voyager 2.
Oh, Voyagers. Okay, there's a bunch of stuff we're going to have to unpack here because, I've got questions. I've got so many questions.
I think that's the point of this podcast,
Yeah. Well, I mean, if nothing else, if no one else gets anything at all out of Syzygy, it's answering a lot of questions for me.
Excellent.
And that's entertaining. So, all right, let us begin this episode on exotelescopes, Emily, with could we please define what's a telescope? Should we start there? Could we start there?
Yeah, I mean, I'm being put on the spot a little bit, but I'm going to try and come up with a definition.
Okay.
I would say a telescope is an instrument that measures astronomical events in the universe.
Okay. All right. I mean, I guess if you were to break the word specifically down, tele meaning across distance, far away, scope being to look at, right? And so I would have thought that telescope means looking at something far away.
Well,
as opposed to measuring something which is right beside you.
Yeah.
But, these things are
that's fair.
open
I think
to...
we're a little bit constrained by our kind of very traditional view of a telescope, a thing with lenses perhaps, like Galileo's telescope, or even a more modern version of that with big mirrors that we look at, James Webb space telescopes, that sort of thing. But we're quite familiar with the idea that telescopes can look at something that our eyes can't see.
That is true, yeah.
Right?
Yeah.
We've got radio telescopes, we've got gamma ray telescopes, all these kinds of
We've got
things.
X-ray telescopes.
Yeah.
We're a very long way from the notion of put your eye up to the eyepiece and look at the thing over there.
And even in more modern times, we've got neutrino telescopes.
Yeah, that's true.
And we've got gravitational wave telescopes.
So we're sort of broadening this out to instruments that will detect things that happen in the universe at large in some way.
Yeah.
Okay. All right, I can deal with that.
And so spacecraft, like the Voyager probes, I think qualify as types of telescopes.
Well, look, for the sake of argument, for this episode, if only this episode, let's welcome Voyager 1 and Voyager 2 into the pantheon of telescopes in the world. what do they do? Everyone knows. Like, I know that Voyager 1 and Voyager 2 were flung off into the void long, long ago. We can get into the details of this in a second. But, like, they've been out there forever, right? And I know that they've got, like, all sorts of instruments and stuff all over them. But it's never occurred to me to ask, what do they actually do? So other than being the ones that are the furthest away, what are they measuring? What do they do?
Yeah, well, both Voyagers still have 4 working instruments on board that are sending back data. The vast majority of that now is stuff about the plasma that they're moving in beyond our solar system, the interstellar medium, and about magnetic fields and things like that. That's most of what the data is that they're measuring now. That wasn't necessarily their first primary design of instrumentation.
That's not where they started.
No, because both probes started off as planet missions, right?
Right, of course.
They were part of the grand exploration of the solar system devised by NASA in the 60s and conducted throughout the 70s.
So can you give us a little rundown of, Voyager to date? Like how did their missions play out?
Yeah, okay. So both Voyager 1 and Voyager 2 they're both almost identical spacecraft. They were both launched in 1977. Fun fact, Voyager 2 was launched a few days before Voyager 1.
Kind of feels like they got the names around the wrong way. Was that an error? Did someone get that wrong?
I'm guessing it was just launch windows, because they were launched in slightly different orbits, slightly different trajectories. Voyager 1 was sent to Jupiter, Saturn, and then at the end of its Saturn mission stayed on to look at Titan, the biggest moon of Saturn. Voyager 2 went to Jupiter, Saturn, and then on to Uranus and Neptune on its grand tour. Voyager 2 remains the only spacecraft we sent to Uranus and Neptune,
really?
amazingly.
The only one?
The only one. The only
That's
probe
amazing.
we sent that
I
way.
guess that points out just how far away these things are.
Yeah.
And therefore how big a deal it is to get something to them.
And then it was kind of the fact that after those primary missions, they were still working. So they just carried on their mission. They were always designed to maybe leave the solar system one day. And it's turned out that both of them have.
Turns out. I mean, look, if they just keep going, obviously they will leave the solar system. But it was a big question for a very long time as to whether or not we would ever know, because is anything even going to be working on them by that point? We've talked in previous episodes of this podcast just recently about things like Hubble, which, keeps going strong. Far, far after the original mission parameters have long gone. So, well, it's still working. Let's use it for stuff. And there's a long history of this. But I think Voyager is really kind of taking the cake on that one.
Yeah.
Because they're still doing stuff long, long, long after anyone thought there's no right for these things to still be working.
No, they had a 5-year mission plan.
Yeah.
And they're now 47 years old.
I mean, we should all be that lucky, right? I want to have that kind of energy when I'm that age. So, can I ask, where are they?
Wow. That's a very exciting
kind of the
question.
point, really, of the episode.
So for both of them, we can skip over. They did wonderful things with the planets in our solar system.
Yada, yada, yada.
Wonderful
yada.
images,
Yeah,
blah,
yeah,
blah,
yeah.
blah, right? Let's start with Voyager 1. So Voyager 1 was the first telescope to leave the solar system. And it left the solar system in 2012. And you can ask, how do we measure
How
that?
do we know?
How do we know?
Did they close the door on the way out? Like, how did that?
Well, so they left the part of our solar system we call the heliopause.
Right.
And that is, the heliopause is the limiting sort of zone where you have the sun's solar wind, which has the maximum influence and very close to the sun. And then you have the interstellar medium, which is the plasma that sort of sits in between stars. And so the end of the sun's sort of solar wind, where it hits up against and it's neutralized by the interstellar medium, that's the heliopause.
Right. Helio sun, pause, having a little break.
Yeah.
Yeah, okay.
Yeah. So to give you a sense of scale, so remember that we talk about astronomical units quite a lot.
That's the average distance from the Earth to the Sun is 1 AU.
Yep.
I've learned something.
So we're 1 AU from the Sun right now. The Kuiper Belt, which we're going to come back to, which is kind of the icy debris scattered disk.
Where the comets come from.
Beyond Pluto, where comets and things come from, where Planet 9 may well be.
Yep.
That's about 50 astronomical units from the Sun.
50. Wow. Okay.
Yeah. The heliopause is about 123 astronomical units.
Okay, right. And so Voyager's already done that.
Yes.
It's a long way out, isn't it?
In fact, Voyager...
Because the Kuiper Belt is like, that's significantly beyond like Pluto, right?
Yes, yeah.
Wow.
Pluto's a bit inside the Kuiper Belt. So I think Voyager 1 is now at about 166 astronomical units away from us, and Voyager 2 is about 138.
Wow. That's a really long way. Really long way. I have a distant memory of early episodes of this podcast in which we had a few discussions about, I think there was a headline which is, another milestone reached by one of the Voyagers. And, in order to get some press attention, the Voyager team will once again announce that Voyager has left the solar system, but for reals this time. Because you can have different definitions of, well, when we talk about the solar system, we're actually talking about this. So maybe now would be a good time to sort of pose that question to you, Emily. How do we define the solar system? Where does it go from and where does it go to?
Well,
where does it end? Is it the heliopause? Like, are we settled on heliopause? That's
I think for this purposes, these spacecraft, we definitely settled on the heliopause.
Okay.
Now, it's true that that's not sort of like a giant door that you can just rock up
there
to
isn't a
open.
big dotted line in space.
Yeah,
So we're over it now.
Yeah, you pass here, then you get 200. It doesn't work like that. So there's a detection that has to happen to say that actually we've transitioned from the influence of the sun to the influence of the interstellar medium.
Oh, okay. So you're detecting that.
Yeah, so
Right.
that's a detection that the spacecraft had to make, and actually what the limits of detection and so on can be a little complicated, which was part of the reason why it was quite hard to define exactly where the heliopause was going to be. But also after the spacecraft had traversed it took a few months to say, we really are in, outside the sun's solar wind influence now.
How long does it take for something to get from that distance? Like if Voyager says, ping, I've got some data, and sends it back, how long does that take?
Currently it's about 23 hours for a signal to go one way between the Earth and Voyager. And this came out just recently, actually, because there was, in fact, I think it was just yesterday, there was a news article that Voyager has reconnected because we lost contact with it for a little while.
Oh, right. I mean, I know that's happened a few times.
Yeah, but most of it was planned. But this time it was in October. We lost contact with Voyager 1 when we weren't really sure what was going on. So it takes 2 days basically to figure out you've lost contact with it because you haven't had a message for a while, and then you wait a little while to see if it's coming and didn't come again.
Can they can send messages the other way?
Yes,
presumably.
But of course you've got to wait 2 days. So you send a message, hello, are you okay? And you've got to wait. So that takes a day to get there.
I mean, it's just...
And then you've got to wait a day for it to come back.
How staggering, though, is it that, like, even the distance aside, I'm imagining trying to send a message over that distance. And when you send a message from the Earth, it's like, it's not a laser beam. And even if it was a laser beam, that wouldn't be a terribly fine dot by the time it gets out that distance. But it's not even a laser. Like, this thing is fanning out in huge... So that signal would be so weak by the time it gets to where it is. But that's with all the power that we've got down here on Earth to be able to send that. Voyager's tiny and has almost no power at all, and it's still able to send something that we can detect?
Yeah.
Like, that's madness.
I mean, we have to use some big dishes.
Oh, yeah.
Yeah, right.
Yeah.
So this is what the Deep Space Network is, which we've mentioned before on the podcast. It's Deep Space Network is used by a lot of different missions to the Moon, to Mars, and the Voyagers as well.
When you talk about, I mean, I know we have talked about it before, but my brain is very small and has limited amounts of storage. So when we talk about Deep Space Network, like this is a network of large radio dishes around the world?
That's right, yeah, detecting in different frequency bands. So NASA noticed that Voyager 1 didn't send its sort of check-in message to say, hey, I'm all good, things are going well. So... They thought, actually, right, it took a couple of days to realize that this was, weren't receiving messages. And then I thought, well, let's just check the other frequencies, the other of signals. Because normally Voyager is broadcasting what's called the X band, which is where it can actually transmit a reasonable amount of data. It's not huge amounts of data, but its bandwidth is a bit bigger.
Yeah.
So X-band is where it tries to send messages. They thought, well, sometimes it likes to communicate on the S-band, slightly different band. So they went over and moved all the detectors over to the S-band, and
Turns out there it was, just hiding in the S-band. Does that mean that it's what was it, the X-band? Does that mean that wasn't working?
Well, it means that Voyager's very careful with its power management,
right?
And it has to make a lot of decisions all by itself without us intervening. So
it's got to be running on the equivalent of like a AAA at this point. Like hasn't got much there.
No, but computationally, it needs to be able to make decisions on the fly without having to constantly be controlled from Earth. And this is true when you're doing planet exploration as much as going beyond the solar system. So Voyager had picked up that the X-band transmitter was going a bit haywire, using up a bit too much power, and so just decided, I'm not going to use that anymore. I'm just going to go back to S-band.
Which is pretty clever when you consider that this thing was built in like the mid-70s. When did it launch?
1977.
And if you think about the amount, like the state of computing back then, like you could build big, relatively powerful for the time computers, but that's not this. They didn't put a supercomputer on this thing and fling it off to the far side of the solar system. This would have really limited computational. So the fact that it can do any of this at all,
indeed,
is pretty staggering.
And what's exciting, I think, also about the story is that Voyager 1 hasn't transmitted on the S-band since 1981.
It's amazing it even remembered it was there.
Yeah, this is just such a relic, isn't it?
So I love the fact that when they didn't get a signal, all of the people sort of trying to figure out what's going on. It's like, hang on a minute, there's this other thing that you might have done, hasn't done it in like 40 years. But maybe let's go and have a look. It turns out that's where it was.
Yeah, exactly.
That's awesome.
Yeah, it's really cute.
So still going strong?
They're still going strong.
Excellent.
So cool things about the Voyager missions. So as I say, 77, they were launched. There was a big involvement from Carl Sagan, lots of different missions and programs at that point. But part of his contribution to Voyager was the production of the Golden Record.
The Golden Record, yeah.
So both Voyager spacecraft. I keep saying Voyager 1 because it's kind of the more famous and it's the one that we hear about a bit more. But actually, Voyager 2 needs to, come out of the noise a bit because Voyager 2 also has a golden record.
They're both cool. They're both. There's no favourite children.
That's right. That's right. Yeah. So the golden record was this disc that has
literally a long playing record.
Yeah. Yeah. Exactly.
An LP.
An LP, and it's got all sorts of stuff on it, just like. It must have been a very different era when you think about it. If you think, let's go put some stuff on a spacecraft that might go out into the galaxy, that might be picked up by other people, beings, whatever, at some point in the future.
Minute chance, but it's a chance.
Yeah.
And let's take that opportunity. And so that record was sort of, let's put like stuff about the world on it. Yeah. And it's the 70s. It's like... the end of the hippie era. There's still a bit of flower power going around. Carl Sagan probably taken a few drugs. What's on the record?
Well, there's lots of cool things. So there's lots of, there's some spoken voice, some humans just talking, lots of different languages, greetings, and many, many different languages.
So it's not just sort of, Western white men doing all of this.
There's still a reasonable number of them.
Right, but they've tried to be at least a little bit representative. Okay.
Yeah. So there's some photos on it. So there's a photo of Arecibo.
On the as in encoded onto the LP, so digitally.
Yeah.
Yeah.
So there's a photo of Arecibo. There's a photo of a person eating an ice cream, a person drinking a drink, and a person eating a sandwich or something.
Cool. Okay.
Yeah.
All right.
I mean,
aliens are going to get a very odd sense of what we are and what we do, but there we go.
And
Arecibo, a radio telescope that is no longer there.
Well, that's why I found that a little bit sad. There's something a little bit. I don't know. It's like a time capsule, isn't it?
Yeah. Because what happened to Arecibo? That's the big one, which is built into. It's one of these radio telescopes that's literally built into a cavity in a hillside, right? And so it's not one of these big steerable. Well, it is steerable, but it's not. The whole dish doesn't move.
That's right.
It's just this big crater lined with a radio telescope over which the receiver could move and so steer it in various ways. But it literally fell apart. Right? Not that long ago. A
big
couple of years
storm,
ago.
and then some of the big rods holding the suspensions for the receivers fell onto the dish and really damaged it. And at that point, they decided we're not going to continue to.
It'd be really sad if aliens come to Earth and go, radio telescope dish looks really cool. Can we visit that? No, it's gone.
Yeah,
it's gone now.
it's interesting, isn't it? Yeah, and music. There's lots of music. So this has got. I thought, oh, this is going to be cool. We're going to get some good clips. We can put them on the podcast because that's music is an audible format. So here we go.
Perfect.
Let's do this.
What have we got?
Yeah.
not so much. Not even by 70s standards.
Well, this was what I found rather disappointing. Whoever designed this, and maybe Carl Sagan himself, clearly were not into popular music.
Oh, that's a shame. What's on it?
There's lots of traditional folk music from different cultures.
Okay, good.
Sure,
representative.
Good. Yep. There's some classical music. Fine.
Western classical music, presumably.
Yes,
because that's the only.
Yep.
kind.
There's some jazz or jazz song. Fine. The most recent popular music was a song, I think it was by Chuck Berry in 1958.
Oh, Johnny Be Good. You must know Johnny Be Good, right?
Yeah. I
mean,
think
it is a classic of the genre.
But I was like, why are there no cool 70s? I quite like 70s music.
Yeah, but I mean, look, Emily, to play devil's advocate for a moment, you will get to this when your child gets older. We can't even decide on music to play in the car. So trying to decide on what songs, contemporary songs, to put on a golden record, to put on the Voyager spacecraft, that would have been a very, very long and heated committee meeting.
But you could have got a short list together pretty quickly. I mean, you could have put Rocket Man.
That's true. Bit of Elton John. That would have been good.
That would have been good.
With a picture of him and his...
Bit of David Bowie.
He was pretty crazy in the day. Like, he had amazing stage costumes, and David Bowie as well.
Ziggy Stardust.
You're right. We missed an opportunity there.
Yeah.
Again, though, you run the risk of aliens coming and going, these guys, we want to see these guys. Like, they're like, one of them's dead and the other one doesn't look like that anymore.
Yeah.
So you get a very different sense of what humanity is like,
Yeah,
I think.
yeah.
But anyway.
And there was a recording, this was the other little fun one I found, from Carl Sagan's son as a child.
Ah,
so
that's pretty cute.
Yeah, he's not a child anymore.
No.
Nick Sagan is well into his 50s. But
It was a while ago.
time, it's a weird thing, isn't it?
Yeah.
You sort of think these things are somewhat immortal. But yeah.
It is, I mean, it is an interesting episode in sort of space exploration and early, I guess, humans thinking about our place in the universe. There is vanishingly small possibility, let's call it 0% chance, that any intelligent life will come across these things and be able to decode them. Like, it's just, it's not going to happen. But it doesn't stop the wishful thinking of, well, if someone did, what would we say to them?
Yeah.
So
or
it's
even,
a cool exercise.
Even would we do it today?
Yeah.
Or are we too nervous about... Yeah, it's interesting.
Yeah. I mean, it didn't stop us for episode 50, where we broadcast this podcast
42.
off to 42, of course. We broadcast an episode of Syzygy off to the stars from here at the university's campus using a, I'm sure, highly regarded astronomical technique of just basically turning a telescope around and saying, beam this that way. But I'm sure it worked.
Yes.
And so we've done our own bit there.
Yeah.
Yeah.
So it is interesting. I mean, what's the only more recent example I can think of this kind of... I mean, we put stuff on Mars. We put stuff when we sent Perseverance and Opportunity. There was a whole lot of stuff on them that were like kids' paintings and all sorts of little messages from people. They sort of crowdsourced, but it was much more kind of have your stuff on another planet rather than here's a time capsule of Earth, or here's a something to decode what humans are like if you're not human.
Yeah, exactly. And so, this ridiculously, vanishingly small possibility still sits there in the back of our minds as, but maybe. And it's kind of in the face of just how ridiculously large the universe is, maybe we could just put a little bit of ourselves out there and something might find it and know a little bit about us.
I think we do have an archive of Wikipedia on the moon, if it's ever needed.
Good. Should we ever lose that,
yes.
It'll be handy to go and retrieve it.
Yeah.
That's handy.
Yeah.
Cool. Okay.
Yep.
So, fun facts about Voyager.
Yep. Do you want some more?
Yeah.
Oh, okay. Yes. We have actually done a previous episode on Voyager. I should have picked this up when you mentioned it. We did one. It was episode number 79.
I knew we'd done one, but it was a while ago now.
Yeah, it was June 2021. That was when Voyager sort of came across a hum in the plasma.
That's right.
Of the interstellar medium.
That's right. Yeah.
That was quite a cool, fun thing. So we have spoken about Voyager 1. I don't think we've spoken particularly about Voyager 2. So maybe we should turn our attention to Voyager 2
Works for me.
a little bit.
Works for me.
So Voyager 2 left our solar system a little bit after Voyager 1. It left in 2018.
Whereas Voyager 1 was
2012.
Okay. So a few years
catching
later.
up.
But we're talking, big distances here.
Well, yeah, it also went to Uranus and Neptune. So
it had other things to do.
It was busy, yeah. There's another recent story that I saw, two recent stories that we've seen about Voyager 2. In October, they did actually have to turn off one of its instruments because it was starting to get a little bit buggy and draining too much power. So that was a little bit sad. So that was the last plasma science instrument that was running outside of the solar system.
Right. But that one's gone now.
So that one's gone. And then even more recently, just a couple of weeks ago, there was a reinterpretation, basically, of one of Voyager's very famous results. Voyager 2, this is. So Voyager 2 went to, as we said, Uranus and Neptune. When it went to Uranus, I think it was, they saw a really extreme magnetosphere around the planet. And they thought, this is really kind of odd. We weren't really expecting this.
Magnetosphere, as in sort of... Like the Earth has a magnetic field, right? Where it's often depicted as like there's a big bar magnet down in the middle of the. There isn't a big bar magnet down in the middle of the Earth, but there's the equivalent thereof, and we have a magnetic field, and that actually helps to protect us from all the stuff that's coming from the sun, and that's what gives us aurora and things like that. And Neptune or Uranus
Yep.
has something similar.
Yes.
Right.
Yeah, and it was they were looking at the charged particles and how clustered they were in the kind of regions of the magnetic field of Uranus, and it was like, well, this is really quite strange. We weren't expecting it to have such an extreme magnetosphere. Fine. Anyway, move on. 40 whatever years later, we're back and reinterpreting this, and actually, it turns out that we were just lucky or unlucky, depending on how you look at it. And it looks like what's happened was that there was a bit of a solar burst that came along and got out to the edge of the solar system and just happened to be influencing Uranus at the time that Voyager 2, the only spacecraft we've sent to Uranus, went past. And
so Voyager 2 got this sort of enhanced sense of, wow, Uranus has really got this strong magnetic field there and interacted. No, that's just random.
Yeah.
Happened to
4% chance of that happening, apparently.
Cool. Still, that's the nature of coincidence. Really unlikely things happen all the time.
Indeed. Yeah. So that was kind of cool.
One thing I was going to ask, Emily, do we know how? It's been going for decades now. Right, so the little AAA batteries inside them, like they'd be long gone.
Plutonium reactors.
Plutonium. I was about to ask, how are they powered? Like they're nuclear.
Yeah.
Right.
Yeah.
Wow.
Yeah.
Yeah.
But even nuclear reactions can only go for so long.
Well,
right?
exactly. I mean, it is quite extraordinary.
Yeah. So we're not 100% sure how long the plutonium reactors will keep the spacecraft powered, but it certainly is limited, right? Because the decay of these reactors is going to stop eventually.
Will it get to the point where? I mean, it will eventually, but at what point would we just not be able to reach them anymore? Like they're just so far away that we can't even detect them or signal them anymore.
Well, let's sort of turn it around and let's start with thinking about where they're going to be.
All right, let's do it that way. That makes much more sense.
So they're currently just gone out the heliopause. Both of them are just sort of not too far from that barrier.
Not that long ago, they both left the solar system and they're now in interstellar space, which is awesome.
Yeah.
That is so cool.
So they are going to get a little bit further and further away. In about 300 years or so, they'll be in the Oort cloud. Now, we didn't talk about the Oort cloud, but the Oort cloud is this extended area of just icy bits of blobs and stuff. It's a sphere kind of centered on the sun. It's got lots of little chunks of stuff. We don't really know a lot about it because it's quite far away, but it seems to be
great.
And
we've never been there.
We've never been there. It's about 2,000 to 5,000 astronomical units away. Yes.
I've got my hand up at this point. How do we know it's there?
We can detect particular objects in the Oort cloud.
Really?
Well, they seem to fly into the solar system from time to time.
Right.
And we know that it's a sphere because they come in from all sorts of angles.
From all sorts of angles, right.
Rather than the Kuiper belt, which is on the same plane or disky geometry as the rest of the solar system.
Okay. So my interpretation of that is that the Kuiper belt is sort of, the farthest flung bits of the same disk from which all the planets were created, and it's just sort of, it's the outer crumbly edges of that. The Oort cloud is spherical around a central, very massive thing called the sun, which has a spherical gravitational field around it. And so this is just, you've got a spherical geometry, you've got a spherical gravitational attraction, you can have a spherical cloud that is not anything to do with the disk that formed all the planets and stuff. It's just, this is what's around the sun.
Yeah, that's right.
And how far out does that go?
So it starts between 2,000 and 5,000 AU, so astronomical units.
Which is
it's a long way.
Reminding ourselves that Voyager 1 and 2 are in the 100 to 100 and something.
Not yet 200.
Not yet 200, and this is in the thousands.
Yeah.
It's a long way.
And we don't really know the extent of the Oort cloud, but just a few thousand maybe.
Would it keep going out to, you've got a very long way to go before you start getting to the influence of the next star over. But is this the sort of thing that kind of extends, like the sun's gravitational influence kind of, it in principle goes on forever, but at some point you get closer to the next star and that one takes over and you start falling into that one.
That's right.
So do you imagine an Oort cloud being, is that how we're picturing this? Is basically, it's anything that's kind of caught within the local gravitational low of the sun?
That's right. And you can almost think about it as a boundary as when, if you're inside the boundary, you're more gravitationally influenced by the sun. If you're outside of it, you're more gravitationally influenced by the next star.
Right. Okay. Yeah.
So, basically halfway to the next star.
Cool.
So anyway, but we don't really know how dense it is or anything like that. It's a very mysterious kind of...
Yeah, and it'll be a very long time until we can find out.
Yeah, well, indeed. And then it's going to take maybe 30,000 years for each of the Voyager probes to traverse the Oort cloud.
I reckon their batteries might have run out by then.
Maybe. But if you really want to know how long it's going to take to get to the next star, if you want to sort of hitch a ride on Voyager, now none of these, neither of these craft are actually headed towards a star.
Right.
That's important to
We didn't
know.
aim them that way.
Well, no, and it would be very difficult too, because you'd be aiming at a very, very tiny pinpoint in a very, very big galaxy.
Yes. Right? Yes. The best I'd imagine the best you could do is sort of fling them in the rough direction of a star.
Yeah.
But by the time you get that far, you could be a very, very long way away from that star.
So the chances of either of these telescopes hitting anything, if you like, or getting close to any other star is almost negligible. They're not going to do it. Anyway, but if they were, if you want to think about how long it's going to take to get to the distance of the nearest star, Proxima Centauri, that's 40,000, maybe even 50,000 years. So it's a long time.
That's a big commitment.
But this is why we don't have images of exoplanets, because we're not visiting exoplanets to get close-up images of them and things like that.
Yeah, it's
easy to gloss over.
Even on this podcast, it's easy to forget the scales, and we get very used to there. From time to time, we'll be talking about things which are, forget about this galaxy. We're talking about like going back to the very beginning, the like time and space itself, with 13 billion light years away or more, right? But even within the confines of a galaxy, the distance from one star to another on our human scales, and that's what we're dealing with here because we made these things and flung them off into space, is ridiculous. Like, the distances are just mad. Anyone who thinks it's going to be trivial to just, we'll just go and find a planet around another star somewhere. And of course we won't. No. Short of something like Interstellar, where we can find like a wormhole somewhere, which, by the way, we don't even know whether they exist. So, forget that. It's just not happening.
No, 40,000 years you've got to sit around and wait for this to come around. Yeah, so it's... Anyway, I thought it was interesting, though, just to give you the scale of things.
How fast are they going? Do we know?
Yes, I haven't written down the numbers, but they're quite quick. 'Cause you-
Yes, but that can encompass a lot of things. This is a podcast which deals with very large numbers. So
Yeah.
what kind of scale are we dealing with?
I think it's a few hundreds of kilometers per second. I'm not sure. Maybe it's not hundreds. Maybe it's tens. It's in that-ish range.
Fast.
Yes.
Yeah, per second.
You have to be going fast because you have to exit the sun's gravitational influence.
Right. We talk about escape velocity for the Earth. You've got to send a rocket up into space for it to be able to leave the Earth and actually, get away. It's got to be going fast enough. And the solar system has its own. The sun has its own escape velocity, and you've got to be going faster than that. Otherwise, you sort of keep going and then stop, and then you come back again, which is not what we want.
And
in
this
case.
this is why not everything, as we're going to talk about, I think, in a little bit, not everything is going to become something that leaves the solar system. Not every spacecraft, not every telescope we send up into space will leave the solar system. Not by a long shot. Not even Elon Musk's Tesla will leave the solar system. It's not going fast enough.
Shame he's not on it. Sorry, did I say that? Yeah.
Anyway. So, yeah, a few tens of thousands of years if you want to be at the next star. Okay, that's probably outside of the range of the instrument data gathering capability, the battery life, etc.
I think we will have lost contact.
The signal
by then.
range,
Yeah.
exactly.
Yeah.
Yeah. In fact, we're predicted to lose signal with both the Voyager spacecraft around about 2036.
Right.
Because they'll just be too far away. The signals will be too faint.
Yep. Even so, that's still a dozen years away. Like, that's over a decade away.
Yeah.
That's extraordinary.
That's really good. That's really good. Now, there is worse news, I'm afraid, though.
Oh, okay.
It's looking like Voyager 1 is starting to run out of power. It may actually stop collecting data next year, 2025.
Right. Because as it runs out of power, presumably it just sort of starts shutting things down.
Yeah.
Bit by bit.
Yeah.
Yeah.
So it will start turning off some of its remaining 4 instruments to keep preserving power so it can still send basic data, telemetry data, back to Earth. So, yeah, it could be starting that process actually quite soon.
Next year. Yeah. And by the end, I mean, so the last thing that it switches off is basically saying, I'm here.
Yeah.
I'm here now, and that's all we would get. And then eventually nothing. Yeah. It's a bit sad, isn't
It
it?
is a bit sad. Yeah, and Voyager 2 maybe up to 2030. So
Okay.
a few years.
Okay. So in terms of actually measuring their surroundings and sending us useful data as a far-flung exotelescope, we've got anywhere from sort of a year to 5-6 years. And after that, it's just the knowledge that they're out there pinging away.
Yeah, and in a lifetime of 50 years or so, that feels really soon, doesn't it?
It does rather, yeah. I'm imagining a whole bunch of people who their jobs is still on the Voyager team, staggeringly. They sort of keep coming into work each day going, am I still in a job? Do I need to look for something else? Suddenly, that's just around the corner and they've got to start looking at something else. Yeah, that's wild.
It's interesting, isn't it? But the good news is we will potentially have some more telescopes that do leave the solar system.
Okay,
So right now, as we sit here today, there's only the two Voyagers.
just the two.
Yeah. Do you want to take a stab at how many more we might expect? How many space telescopes might leave the solar system?
That are currently
That have been
going.
launched already.
Yeah. Not potential future ones, because
No,
that
no.
could be limitless.
Well.
So I've no idea. I mean, let's go for the same number again. There's another 2?
Not bad. There's 3.
3.
Yeah.
Okay.
Now, so there's 3 telescopes that will leave the solar system and their current trajectories and velocities. The bad news is 2 of them we've already lost contact with. They've already
Rats.
shut down.
Rats.
That's Pioneer 10 and Pioneer 11.
Right. And like completely, like, do we even know where they are?
Well,
we just...
no, we only have their last sort of coordinates.
Right. Okay. So we're sort of extrapolating a dotted line from last seen here and going, at some point, they will fling their way out.
Yeah. So Pioneer 10 was launched in 1972. We lost contact with it in 2003. And it's expected to leave the solar system in 2057.
Wow. Okay.
It's not going super fast.
No.
Pioneer 11 launched about the same time. We lost contact in 1995.
So it's been a while.
But it's expected to leave the solar system in 2027.
And did they have anything on board sort of saying, hello, we're here?
They did, but they've gone. Everything's shut down. They're just lumps of
No. But what I mean is
aluminium
like the record.
Oh, yes.
Were they carrying anything of
Yes,
interest?
the Pioneer spacecraft had plaques on them.
Oh, they did, didn't they? Yeah.
With the naked woman and man.
Yep, very controversial. You can't show your ghoulies to the world, to the universe. That's not okay.
Yeah, and then a map of how to find us based on pulsars.
Right, yes, very clever. So a much sort of smaller amount of information than you could fit on a long playing record, even made out of gold. But still showing, we are humans, we made this, and here we are. Come find us.
Yeah.
Which again, controversial. Do we really want to point that out? But hey, there they are. And it's nice to know that even though we've lost contact with them, they are still on course to deliver that payload to the universe.
Yeah.
Yeah.
So
those, you said there were three.
Two,
those are the two that we've lost contact with, but there was a third.
There is a third, and it might not surprise you, this one, when you realise which one it is. It's New Horizons.
It's in the name, I guess.
Well, do you remember when New Horizons went?
No.
Went to Pluto.
Oh, yes.
Yeah.
Of course.
So it was launched in 2006.
It gave us that amazing upgrade on the photos of Pluto, which, yes, the Pluto heart, which, our previous images of Pluto were, here's 10 pixels roughly in a circle, some of which are grey, to, oh my God, look at the detail on this thing.
Yeah.
Absolutely amazing.
And it was launched just around about the time of Pluto was demoted as well.
Yeah. But that's
anyway.
Nothing against Pluto. It's a great place.
It is,
right?
Yeah.
And New Horizons, when did it do all of that?
It got there in 2015.
Right.
So, and then not long afterwards, so it obviously got gravity assists from Jupiter and things like that to get out there. But then after looking at Pluto, it went up into the Kuiper belt, and it was kind of a mission of opportunity to find a Kuiper belt object that it could look at. Mm-hmm. And you might remember this, it was around about 2015 as well. There was a very famous one called Ultima Thule.
I do remember that.
Which then got renamed into Arakoth.
Oh, that I don't remember.
We're
now starting to sound very sort of Lord of the Ringsy, Middle Earthy.
Yeah. And that was, you probably remember the picture if you see it again. It looked like it's like a snowman, but without any features. So it was like a body and then a head just smudged together.
Yeah. And of course, we're out into the part of the solar system where things aren't big enough to sort of coalesce into spheres. They just sort of glom together into random snowman shapes.
It was two like blobs that just actually stuck together, kind of.
Like big balls of plasticine.
Yeah. So that was New Horizons. It's expected to leave the solar system around about the 2040s.
In that same sense of passing
through the heliopause.
Beyond the heliopause,
But unfortunately, it's only expected to be operational until the 2030s. So it may not be sending any messages by that point.
Right. So in total, at some point within the next, 20, 30 years, we will have 5 little messengers out there winging their way off into the void. And we won't have contact with any of them.
No.
By then, they'll all be quiet, but they'll be out there.
Yeah.
Going in different directions.
Yeah, it's quite
randomly
interesting,
off
isn't
into the void.
So when we lose the Voyagers, which I think will be quite emotional for a lot of people.
It's been a long time. That's like generations of people working on that.
Yeah. So when we lose the Voyagers, that will be it. We won't have any contact beyond the solar system for the foreseeable future. There's no planned missions at this stage that are planned to get to escape velocity for the solar system.
Well, I mean, it would be a very difficult sell, right? To set up something which is like, there may not be payoff on this. If it happens at all, for decades. Like, it's going to take us a really long time to get this spacecraft that we're designing now out there.
Yeah, and I think our focus has shifted quite a bit, right? You think about the 70s and these probes, they were sent out to fly by these planets, capture images, and even the more recent missions to the outer solar system like New Horizons and so on. They were always designed to be much more of a, let's find out a lot of scientific information. So they were designed as exploration, first of all, right? let's just go and see what's there.
Yeah.
Right?
Yeah.
Because we don't know. We've not been there. We're now in a bit of a different phase now. We're now more in a characterization, finding out more. I mean, think about how many Jupiter missions there have been in the last few years and are planned for the next 10 to 20 years. There's heaps. Because we really want to understand Jupiter, because we really think there could be potential for at least life-friendly environments in some of Jupiter's moons. It's not about doing it for the first time anymore.
Yeah, I see what you mean. I mean, it still amazes me that we've had a grand total of one thing go to Neptune. Uranus and Neptune?
And Uranus and Neptune, yeah.
I mean, that's extraordinary. But then again, Jupiter is like the closest of the really big outer gassy planets, right? That's hard enough to get to, but it's sort of, it's there in this relatively comfortable zone of, look, there's plenty of stuff we can do at Jupiter. We can learn a lot from going to Jupiter. And there's lots of moons, including some which could be really interesting to look at. So that seems like a really good focus. Let's do that. Saturn is way harder because it's further away by a long... Like, it's the same distance again to Saturn, right?
Just about, yeah.
Just about. And, like, Saturn's really cool and everything, but Jupiter's far easier. And there's loads of stuff that we can do at Jupiter. Forget about beyond that. So making the sell for, let's go and learn more about, like, the Kuiper Belt, whatever. That's a really hard sell.
Yeah.
We've got plenty we can get on with in the more immediate horizons of sort of, Jupiter.
Maybe, yeah. I do wonder, though, if these things do come full circle, because you think about where we are with, say, exoplanet exploration. We've found thousands, as we've talked about exoplanets. We found out that the most common exoplanet is a bit bigger than the Earth, a bit smaller than Neptune.
Yeah.
Does that mean that Neptune becomes a bit more interesting? Because we want to understand more about exoplanets, we kind of think, actually, we might need a bit more data on Neptune to kind of understand how you bridge that gap, basically,
it's a
between
good
the two
point.
planets.
And is sending something there the best way to do that? Or is there more ways that we can gather information about a far-flung planet in our own solar system? It's funny,
can do
isn't
different
it?
stuff, yeah.
But it strikes me as this strange middle ground where we can learn so much about things which are so far away. They're around literally other stars. But getting to the ones which are closest to us is actually still really hard. Like, it's this strange...
Or just getting any information about them.
Yeah.
Neptune doesn't go in front of the sun from our point of view on Earth.
No.
If it did, we'd have a lot more information about its atmosphere.
That's true, because you could use the same techniques that we use to look at exoplanets with the light from the star coming through the atmosphere of the planet. But no, we're not going to see that because Neptune isn't going to go between us and the sun unless something really bad's happened. I think we've got bigger problems.
Yeah, something's gone wrong if that happens.
That's
I mean, that's not to say we can't learn some things. We can,
Sure.
because from the light it does reflect off the surface of Neptune, but it's just different.
Yeah. So most of the techniques which we're getting really, really good at for exoplanets, mini Neptunes far, far away, much harder to do in our own neighbourhood. And it's this strange irony.
It is, isn't it? Yeah. So I think I will come back again, I think, just as we're wrapping up, to the idea, the emotive part of the Voyagers, because I couldn't help but feel sad learning that, Voyager 1 might finish up its mission next year.
Yeah.
So why are we so emotionally attached to these space telescopes?
These machines, these plutonium-powered aluminium lumps with antennae on them.
It's interesting.
It is interesting.
I mean, we have some... Yeah, maybe we have the same emotion about ground-based telescopes or even space telescopes. Maybe we have the same emotion about neutrino telescopes. It's not my field, so I'm not as close to them.
Yeah, I don't know. I wonder.
It doesn't feel like it, does it?
Is it something more to do with... Like, the closest thing that I can think of are things like the Mars rovers, right?
Yeah.
Where there's a lot of emotion tied up with these little things. And with the Mars rovers, it's surely partly because it's not that hard to anthropomorphize them, or if not, turning them into sort of, giving them human characteristics, giving them pet-like characters. Like they're like little creatures running around on the surface of Mars. It's not hard to do that. And we humans do the similar sorts of things with our cars, and I wonder if it's something to do with moving around.
Yeah.
That in order to take on those characteristics, it needs to be something which moves. You see it with any kind of sort of, as soon as you get something like a robotic vacuum cleaner, suddenly it's possible to turn that into a little creature that's running around your home in your mind. Isn't it interesting that even with something like Voyager, which isn't like, it's not like it's autonomously changing direction in space and sort of whizzing off over here and like running around the place like a little creature. Like currently it's linear. It's not changing direction, but it is moving. It's off there, flying away. And somehow, psychologically, we can attach to that some sense of it's almost alive.
And it represents a very specific period in time.
There's that too.
Which I think even the rovers don't quite do to the same extent, right?
Yeah.
Because the rovers, although they've been there for a very long time, they don't... You think about what the 70s were like. Well, I wasn't alive in the 70s, but... You have the glorious kind of hindsight is 2020. Was it a simpler time? Were things easier and more fun? No, because
there was
the
the whole
70s were
Cold
awful,
War thing,
for other reasons.
There's lots of other things going on, but I know what you mean.
But there's that kind of nostalgic element to it. And to think that, what were people thinking? What was life like? It was very different.
Well, it was, and the opposite. The optimism that went into, let's stick a golden record on these things, because even though we know, like Carl Sagan's not an idiot. He knew no one was ever going to put that on their turntable and read it back and see those pictures and hear Chuck Berry and whales burping and all of that. It wasn't going to happen. Regardless, this sense of optimism, which is, well, of course we're going to put a record of humanity on this thing, because... why wouldn't you? We are exploring the universe now. We've gone to the moon. We've done that. And now we're going to the other planets and we're going to the universe. And that's an incredibly optimistic time. Sure, that's sad when that finally just stops winking back at us. Yeah. Well, Emily, I wasn't expecting that to go quite so deep there, but I mean, in retrospect, it makes sense, right? This is deep stuff. This is the stuff of, we talk many times on this podcast about how astronomy, cosmology, the universe, this is awe-inspiring stuff, and the only way that you can deal with that as a species, I think, is to sort of explore it with your heart kind of on your sleeve a bit. It's
definitely okay to have feelings.
Yeah. In fact, it's more than okay. I think it's requisite. I think if you're not doing this stuff with, a sense of wonder and awe and some emotion, then go and find another job, because, it demands that. So it will be a sad day when all of these things finally stop, because we won't have that anymore, except for the idea that they're out there somewhere. Can't see them anymore. We don't know where they are, but they are out there carrying their golden records and their whale song and their Chuck Berry, which is kind of fun. Listen, Emily, if people wanted to get in touch with us and just say how touched they are by the notion of interstellar exploration, then how could they possibly get in touch?
Well, you don't have to wait 24 hours for your message to be received.
No, it'll be received quickly. You just may not get a response.
Well, at least the message itself will travel at the speed of light, but a very short distance.
That's right.
If you go to the syzygy.fm website and go to the comments here box, write your things and push go.
Yeah. And look, we promise that will reach our email inbox, and we promise that it will be read. We just don't necessarily promise that we'll do anything about it. But look, if you send us a message and you've got ideas, you've got thoughts, then we will try. That's the best I can say.
I think we should start thinking about season 3.
I think we should. So if you've got ideas for the next season of Syzygy, this one's been about exo stuff. What should the next one be about? All sorts of possibilities. We're going to be doing seasons of, let's say for the sake of an argument, 6 episodes, half a dozen episodes. So if you can see a theme that you would like to explore, you would like us to explore, send it our way. Syzygy.fm. Get in touch. You can find us out there on the social medias, not in the Twitterverse or the Xverse or whatever. We've sworn off that one. But you can find us elsewhere. look us up at SyzygyPod is where you're going to find us. Other ways that you can interact with us here on the show, you can tell everyone you know. You can spread the word, and you can give us a review, a couple of stars and a review on your podcast player of choice. That helps us to rise up through the noise. And you can go on to patreon.com/SyzygyPod and become a financial supporter of the show. Help the electrons keep flowing through the website and to help us do what we do. But otherwise, Emily, you're about to get on a plane. We've still got one episode left in this series.
We do.
We're going to have to do this by, stringing a couple of cups with a piece of string between here and New Zealand.
I think we can probably work on the S-band, though.
Oh, okay. Look, if I don't see you on the X-band, I'll switch over to the S-band and
Yep.
see if we can catch up with you there. We've got one more episode to come. Emily, I will catch you then. Have a great trip.
Thank you.
Talk to you soon.
See you later.
Bye, everybody.
I mean, don't even talk to me the day that Hubble stops working.
You can just be a mess.
Do you think we're going to look back on today in that same sort of nostalgic way, in the sense of, I mean, yeah, maybe we will. I think I look, there's parts of Kepler that I look back on and think.
Well, the Mars rovers, as we
Yeah.
said, that's happening now, and I think
James Webb will one day.
Yeah, and maybe not with the same kind of poignancy, but people definitely, get a bit upset when the little buggy driving around on the surface of Mars after many, many, many years just grinds to a halt and gets covered up in a sandstorm. That's a sad day for this little robot. Yeah.
Maybe not as sad as the day that they do turn off the Large Hadron Collider or something like that at CERN. That will be sad, but I don't think it'll capture people's hearts.
I don't think it will. It'll be really sad for the people who've worked on it for so many years.
Yeah.
But maybe that's just such a difficult thing to conceptualize, right? It's like turning off the Death Star. It's not quite the same as this little. I mean, we even give them these names, the Mars rovers and Voyager and Pioneer and so on. We give them these names which are optimistic
loaded words.
Loaded names. And we do that for a reason. Yeah. We do that because we're endowing them with our hopes and dreams, Yeah. And so when that little bit turns off, that's a poignant moment.
Who said that astronomy is not about humanity?
Wow, indeed.